Right, time for lesson 71, trinomials with factors. And the second part of the lesson will be called subscripted variables. I don't know if you can read it, but that's what it says. Hopefully you got down factoring. I did the little extra factoring video and you had some practice with factoring trinomials. This one's not much harder than the first one, so even if you didn't get factoring the first time, there's still an opportunity to learn it during this lesson. Just make sure you don't fall behind on factoring. If you have questions, just email me or put it on the help board and I'll be happy to help you with factoring. So this one has this trinomials with factors. What that means is when you look at your trinomials, you're going to have to look for something that's common. That's what a factor means. It's something that's common. Anytime you do a factoring problem from here on out, you want to look and see if there's anything common. That's your first step in factoring, is to look to see if there's anything common that you can take out. So we have our first trinomial. What do you see that's common in that trinomial? I hope you saw that there's an x in every single term. It has to be in all three terms in order to take it out. So I'm going to take out an x. So I'm going to put my x out here, and I'm going to write what's left inside. So we get x squared plus 6x, we removed an x, plus 5. So everyone is short 1x from what you started with. Now the key is when you multiply this back in, you should get what you started with. Just like if we talk about this all the time, if you have 6, we factored into 2 times 3. When we multiply these back in, we should get what we started with. That's all you're doing here is you're taking it apart. And then when you put it back in, you should get what you started with. So once we get here, then we have a trinomial that we can continue to factor. So we carry our x on. Always bring this along for the ride. And remember, you're going to put 2 sets of parentheses when we do trinomials. We say what times what gives me the first term, because these are the first terms. And then I look at the sign, the last sign. This is really important that you learn how to do this because this will help you later. We look at the second sign, the last sign, and if it's plus, we know that both signs are going to be the same. And you can even go further. You can say, what are they going to be? Well, we look at this sign. They're both going to be positive. So we write a plus and a plus. Then we say, what times what gives me 5? Well, there's only one combination. It's really what times what gives me 5, and then add together to give me 6. So our only combination is 5 and 1. So that's our final answer in factoring that trinomial. That was a really easy one. Let's try the next one. This time, here we go again. They're going to say factor. All these directions will say factor. So we say what goes into all of these. Is there anything common in all of these? So we notice there's a 4. And I also notice that there's a B. And I also notice that there's an X. So we can take all 3 of those things out. And we see what's left. Well, we took the 4 out, we took the B out, and we took an X out. So in this one, there's only an X squared left. The next one, we took a 4 out, we took a B out, and we're going to have 1 X left. This one, we took a 4 out, so that leaves us with 20. And we took a B out, and we took an X out. Really, when you're taking something out, you're dividing it, because then we're going to multiply to put it back in. So if I multiply this back together, we would get what we started with. So go ahead, I'm going to write the 4bx, and I want you to go ahead and factor this one. Pause and factor and see if you get it right. Okay, hopefully you tried that. What we're going to do is we always look at the last sign right here. Oh, it's negative. It's a different sign. Difference means subtraction. So we know one sign is going to be positive and one sign is going to be negative. They're going to be different if that last sign is negative. Now we do our reverse FOILing. So we say what times what gives me x squared? Well, it'll be x times x. What times what gives me 20? And when I subtract them, I get negative 1. Well, we'd have 2 times 10, 1 times 20, and 4 times 5. So this would be all the possible factors. Which ones of these, when I subtract, give me a negative 1? Will be a 5 and a 4. You want the answer to be negative, so the bigger one has to go with the negative. And then we always check our outer and our inner, and we get our negative x. So it does work. So that's the final answer. Okay, let's look at this one. We look to see what's common in all these terms. Well, it looks like nothing's common on those. But you're also going to notice that there's a negative in front. That we haven't seen a negative in front in any other problem. Whenever you see a negative in front of the squared term, you have to take it out before you can factor. So taking it out is simply dividing every term by the -1. So I'm going to take out my -1. You can either write a negative or a -1. And then we write what's left. So we take out a negative, so we get x squared. Basically, when you take out a negative, you're changing all the signs. Then we'd have a positive. Then we would have a negative. I know that's right because when I multiply it back in, I get what I'm starting with. Look, -1 times x squared is -x squared. -1 times x is -x. -1 times -20 is +20. So by doing that, we get back what we started with. Now we carry this -1 down. We make our two sets of parentheses. You go ahead and factor this one. Pause the video. Practice factoring. All right, this one's not much different than the previous one. So we're going to have our x and our x. We need a 1. We look at our last sign. I kind of went too fast there. Last sign means it's negative, so one's going to be negative, one's going to be positive. Where you put the 5 and 4, however, does matter. We want it to be positive, so the bigger one has to be positive. So hopefully that's what you got for an answer. Okay, one more of these. This one, look down here, -3x cubed minus 6x squared plus 72x. We're going to combine two things. We can see that this starts with a negative, so we're going to factor a negative out for sure. So I'm going to put the negative out there. Then I'm going to look. We have 3 goes into all of these, so I can put my 3 out here. And we notice that there's an x in all of these, so I can put my x out here. And then we begin. All the signs are going to be changing because we're factoring out a negative. So I'm going to just get x squared here. We took the 3 and the negative out. Positive, we're changing all the signs. 2x. Negative, we divide 3 into that, so it would be 24. Again, we have a trinomial, so we put -3x. And we factor. Go ahead and factor, pause it, factor it yourself, and see if you get what I got. It's good factoring practice. Pause. All right, hopefully you got this one. We look at our last sign. It's negative. What's it mean when it's negative? It means that one sign's going to be positive, one sign's going to be negative. What times what gives me x squared? Right now, these are easy. And we need what times what gives me 24, and when I subtract them, I'm going to get +2. So the combinations would be 1 and 24, 3 and 8, 2 and 12, 4 and 6. Which two subtract give me 2? Well, this is the only one that works. Which one's going to go with the positive? Which one's going to go with the negative? Well, we want a +2, so the bigger one has to go with the positive. And there you go, all factored. Okay, let's go on to the second part of the lesson. This is a longer lesson because it's 2 parts, and I'm going really slow just to make sure that everyone gets it. So let's go to the lesson on subscripted variables. It's actually the same lesson, but I need to do a new screen. All right, subscripted variables. I have a couple corrections to make on this one. It should be 280, I do believe. Oops, hold on a second. It's not working. 280, and this should be NQ. We'll get to that in a minute. Okay, these are just like what we did before, elimination and substitution problems. We have 2 equations with 2 unknowns. We need to get these, we need to either eliminate a variable or substitute, so we have 1 equation and 1 unknown. The difference between these and what you've done before is these things right here called a subscripted variable. These n, we have NNs, NQ, ND, and NQ in these problems. These things are called the subscripts. What this does is it helps us to do word problems and know what we're talking about when we write them down. Like this typically will mean number of nickels, number of dimes, and number of quarters. We use subscripts for different things as we go when we do motion problems, distance problems, these subscripted things will be really handy. So we're just going to do it the same way we did before. We're going to eliminate one of the variables. These are just like, you could just have this as 5x plus 10y equals 125. These are simply variables, but they're more descriptive. They're actually helpful. We actually will use them. So what we're going to do is we're first going to figure out what we need to multiply the second equation so that when we add it, it's going to add up to, we're going to eliminate a variable. So I'm going to multiply this one by minus 10. That way when I add these together, the d's will go away, the nd's will go away. So we get 5n plus 10, I'm going to call them number of dimes instead of nd, equals 125. This one I'm going to multiply by minus 10. So my house is getting noisy again, as normal. Minus 10 number of dimes equals minus 160. So remember, we're trying to get these ones right here will add out. We have the minus, let me include that minus sign. We have a positive and a minus. So we have to multiply that by a negative 10 for that to work. So I'm going to add these together, and we get minus 5 number of nickels equals negative 35. We get number of nickels equals 7. So if you just substituted the x and the y, you can see how this isn't any different than what you've done before. So then we have to take that, the number of nickels, and we take that right up here. So I would have 7 plus number of dimes equals 16. So 7 plus what gives me 16? So that would be 9. So we'd say the number of dimes equals 9. One last problem. This one has NQs in it, and that kind of stands for numbers of quarters. I just want to make sure I copy this right. 290. This actually should be 290 over here. Bear with me while I erase. It's not easy to erase in this thing. Oops. Alright, sorry about that. 290. Shouldn't copy these things wrong. Okay, this one says use substitution, but they make it really easy for you. They put the NQ already by itself. So instead of NQ here, you're going to put what NQ is equal to. It's equal to this. So we're going to substitute it in. So we get 5 number of nickels plus 25 times number of nickels plus 2 equals 290, and then we just solve it. Here we have one equation and one unknown. So you can't solve two equations with two unknowns. You can't solve one equation with two unknowns. So here we go. So we get 5 number of nickels plus 25 number of nickels plus 50 equals 290. We would get 30. I like to say number of nickels instead of NN. And so then equals, I combine these two, and then I'm going to subtract 50 from both sides. And so we're going to get 240. And then we would get number of nickels equals 8. And then we would just take that number and put it back up here where the number of nickels are, and we get number of quarters equals 10. And that's all there is to that. So if you have any questions, make sure you get a help board, and I'll answer your questions for you there. Or you can email me if you're really stuck. Alright, that ends it for lesson 71. If, of course, I can end it. I have trouble ending sometimes.